Remote, hybrid, or in person? We are the Work from Home group, and our team looked at data from the Bureau of Labor Statistics as well as data from our own survey to find how COVID 19 has redefined the way we work and think about work. According to a 2020 Stanford study, remote work accounted for over two-thirds of U.S. economic activity. The study showed how employees both enjoy the flexibility of remote work as well as face new challenges at home, such as taking care of family members. Additionally, according to Global Workplace Analytics, 56% of current jobs allow for some form of remote work.
Thanks, Suba. Now let's take a look at the data. Based on the time series data we looked at, we were able to draw up a table containing data that was derived from January of 2021 to March of 2022. This data was broken up here in this table by individuals aged 16 to 24, 25 to 54, 55 and older, and then the total of all ages 16 and up combined. Here we have a graph of the time series data as previously shown on the last slide. This graph represents the three age groups, blue representing those 16 to 24, red representing those 25 to 54, and green representing those 55 and up, as well as a total of all three represented through the purple line. The graph begins on the y-axis at 0 and begins to increase all the way up to 40,000 as its maximum.
The graph shows a decline of remote workers from January to July, and then generally shows to plateau until November of 2021. There is an increase in remote workers in December to January 2022, with the cause being most likely the Omicron outbreak. The general data shows that workers aged 25 to 55 are the main contributors to the workforce compared to both younger and older age groups. After December's initial increase of remote workers from the Omicron outbreak, numbers continued to decline in the following months.
This frequency table is based on data about the California from Bureau of Labor Statistics. As you can see, the two age groups that had a low relative frequency in switching from in-person to remote jobs were between the ages of 18 and 24, and also the 65 and above. The reason for the younger people not being able to shift is their jobs. Most of the young workers are still in college, so they have a low-skilled part-time job. These low-skilled jobs were usually carried out by physical activity that you can't replace. The most common industries were hospitality, leisure, and retail. The older age group couldn't adapt for different reasons, mainly because the baby boomer generation is the last one who's not a sophisticated computer user. Most of these people were working for their entire life without using computers or barely using them. As you can see it on the graph, both of these two groups are under 10%, which is significantly lower than the other groups of this dataset.
Thank you, Mark. We also constructed a side-by-side bar graph. This graph shows the education level and if they worked remote because of the pandemic or not. The x-axis shows the education level, where the y-axis shows the number of people. This puts the thought that maybe the people with advanced degrees were already working remotely. With all this said, you can see by the graph most people of all ages and degrees worked from home because of the coronavirus and the impact it had on all students. Bachelor's degree and higher had the highest results when working at home during the pandemic and obtaining a degree. All this data is from California Bureau of Labor Statistics.
Thank you, Jordan. Besides studying data provided by the BLS, we also conducted our own survey through convenience sampling. After creating some questions related to working from home, we invited SGSU students to fill out the survey. As such, even though we were able to quickly gather over 100 responses, our results will not be entirely accurate. Still, based on the data we collected, we were able to discover interesting insights about how students view working from home. One of the descriptive statistics we looked at after collecting our responses was the total age of all the respondents. After using the data analysis tool pack on Excel, we discovered that there was a skewness of over 2 and a kurtosis of 4. These values mean that we had a positively skewed distribution and a leptokurtic kurtosis, or in other words, we have a fatter tail compared to a normal distribution. This is accurately represented in our graph since we can see that there is a greater number of respondents aged 18 to 20 compared to those aged 21 or older. We then want to figure out whether respondents answered differently to our survey considering their ages. Overall, the answers were pretty much the same across all age groups. However, one interesting finding was that people in the 23 plus age group had a higher count of individuals who responded that they found it extremely important to work from home compared to other age groups. Yet, most people who were part of this group did not want to give up a portion of their salary to work remotely. In contrast, 19-year-olds who responded that working from home was not a big concern were willing to give up to 15% of their salary in order to work from home. This was surprising to us because we expected people who valued working from home to give up more of their salary in order to do so, but the opposite was true.
Thanks, Alice. We also conducted a chi-square independence test off of the survey's responses. A chi-square test of independence is a statistical test that finds the relationship of two categorical variables, which are qualitative data, so these variables can take on values such as names or labels. Since our survey responses were not quantitative data, we decided that the chi-square test of independence would be the best method for analysis. In our first question, we asked students on a scale of 1 to 5 how important it was for them to have a remote work option. Our next question was a simple yes or no response of if the students would elect to work remotely if given the option. Our null hypothesis was that the variables are independent, meaning there is no relationship between the students who said yes or no to working from home and the importance of remote work. Our alternative hypothesis is that there is a relationship between the variables. As you can see, we chose a significance level of 0.05, so if the p-value is less than or equal to 0.05, we can successfully reject the null hypothesis. As you can see, we calculated our p-value from the observed and expected range of data. Our p-value is less than our significance level, therefore we can successfully reject the null hypothesis and accept the alternative that there is a significant relationship between those students who said yes to working from home and their assigned level of importance.
Thanks, Suba. Our second survey question asked if students would work from home if given the option. Using the point estimator for a population proportion, we assumed that 82% of all SJSU undergraduate students would work from home if given the option, and 18% would not. Additionally, we calculated a confidence interval as follows. We are 95% confident the proportion of SJSU undergraduate students who would work from home would fall between 75% to 89%. As for those who would not work from home, we are 95% confident that the proportion would fall between 11% to 25%. The confidence interval for the proportion of students who would work from home consists of much higher percentages than the percentages for the confidence interval for those students who would not work from home. Therefore, we conclude that a high percentage of SJSU undergraduate students value having a remote work option. Our second question asked students what percent of their salary they are willing to give up to have a remote work option. We used the point estimator for population mean to assume that the mean percentage that SJSU undergraduate students are willing to reduce their salary by in order to have a remote work option is around 5%. We calculated this by using the weighted average formula to give a proper weight to each survey answer. For the students who responded with ranges like 5 to 10%, we calculated the average percentage. Although this may seem like a small amount, the fact that SJSU undergraduate students are willing to take a pay cut at all just to have a remote work option emphasizes how much being able to work from home is important to this population. Our scatter plot looks at the relationship between the age of respondents and the percentage of pay cut. The covariance between the two variables is 0.0173, meaning they are positively related, and as age goes up, the percentage goes up as well. However, the correlation between age and percentage was 0.127, meaning the two variables do not have a strong relationship. As you can see, a 22-year-old student was willing to take the highest pay cut of 25%, but a 30-year-old would not take a pay cut at all. However, in general, the SJSU undergraduate students surveyed were willing to take some amount of a pay cut in order to have a remote work option.
After our analysis, we recommend that employers continue to have flexible remote work options open for employees as is needed and suggest employers keep in mind when remote work leads to more productivity as it could save them money, as well as minimizing the pay cut that may come with remote work, as many students did not want to give up a large portion of their salary for remote work. Some additional data that would have been helpful are demographic data from respondents, insight of industry of professionals, and in general, a larger sample size for our survey for accuracy. In summary, the pandemic has reshaped the way we work, and remote work will continue to be a part of our lives. Thank you so much for listening.